Alright, so I figure this pin, either I ground on this pin to get it out before and don't remember doing it, or it was too short to begin with, because the problem is that if I put this pin in here all the way and I have it protruding out evenly on each side, it actually barely clears these threads, or doesn't clear these threads at all. So it wouldn't really do anything once this got to the end. This would just travel up inside there, which we don't want to happen. I think the design of this is that this pin is supposed to be long enough so that it sticks out on both sides, so that when you get to the point where this is about to go in there, the pin sticking out will hit this edge, and it almost seems like this. See, there's a little groove right there. I'm wondering if that's like where the pin will eventually come around and snap in and kind of like catch, and then cause this to drive this. Now that kind of seems kind of, I don't know, Mickey Mouse too. I don't know. I mean, the other possibility is that originally there was a collar on here, and the collar was held in place by the pin, and then what ends up happening is when this comes up, you know, the collar comes up against the bottom of this and forces this to start turning. That seems to make much more sense to me. But I don't remember taking a collar off of this. I'm pretty sure I just drove a pin out. So I'm going to double check my parts, see if I've got a collar that goes on there. If I don't, I think maybe the thing to do would be to fabricate something. Yes, sir. Well, I had this thing in my pile of bashers and mashers that I use over there by the shop press. I don't even remember what this was. The thing is, it might be hardened. Nope, it's not hardened. So what I want is I want something that will fit down inside of this other part here, which this easily does. This almost does. So I could turn this down just a little bit and it would be perfect. I could hold it in the chuck with this whole section right here, and then when I do all my other, after I'm done with all my other operations, part it off. Alright, so I leveled the lathe. Not really leveled it, but I took it off of the dolly I had it on. That was why it was kind of crooked. Because now I'm actually going to try and do an operation on the lathe. I'm going to try and make this collar that I was just talking about for the Sipp drill press. So this is going to be the first operation I ever really did on the lathe. So I've got this mounted in the chuck. I've got the carriage locked down. I'm using this this tool holder. I'm not quite sure about the angle that I've got it at. What I'm going to try and do is a facing operation right here. So I figure I'll come across, I'll bring the compound in till it just touches off, take a light cut, just see how that goes. Got my safety glasses, and I'm going to run it. I'm going to keep it pretty slow because I'm not sure what I'm doing. With experience, with time will come experience, and this is a Tap Magic cutting fluid. This is not the aluminum formula. This is for all of the metals. So I think this would be good to use. Oh, I forgot. I wanted to get that pan underneath there that I have. All right, let me. Just wiped it on there now to get it off of there. I did put a little oil on the ways. This is the pan that was underneath this lathe when I bought it. And it seems like it's a perfect perfect little pan to fit underneath here and catch chips and oil and stuff, and try and keep the bench underneath fairly clean. I think what I'm going to do is I'm going to use this jelly jar lid. I'll just put a little bit of this cutting fluid in that, and that way I can brush it on easier as I go. Maybe, maybe not. Alright, here goes nothing. Kind of an uneven cut because of the damage on the end of that. It's getting better though. Of course, with this not being a automatic cross feed, I can't really, I'm not doing a good job of feeding this in evenly. Alright, so I'm touching off right there. So now I'm going to take well, I'm not really taking 5 thousandths. I'm changing the compound here by about 5 thousandths, or make it 15 thousandths. But because I'm going at an angle, that's actually equating to less this of it. Not bad. Alright, now probably what I would like to be able to do right now is, if I had a stop here on the carriage, I could back the carriage off, bring this back so that the cutter's not touching the work as I come back. I'm not going to worry about that though. Oil. Alright, not bad. So now that I've got that faced, I'm thinking actually I wanted to turn this diameter right here down to where I want to be on that other thing there. So I've got to check my dimensions there against this. Okay, so this is just about almost on the dot, 1.5 inches in diameter, and what I think I want to get down to is 1.475. So I want to be 25. I want to take 25 thousandths off of this. So I'm thinking for the first cut, I'm going to take off. Trying to take off 10 thousandths, which means I want to move this in 5 thousandths. So first I'm gonna find what I do with my safety glasses. Alright, so what I'm gonna do is bring this over, just gonna bring the compound in. Just touches off. I'm going to move the carriage over. Should be about, that's way too much. Oh, I can't see what I'm doing here. Yeah. First rule of thumb, have better lighting. See, that handle's going to be a problem. I think I just took too much. I think I'm taking too much. Not to mention backlash. skim coat there. There we go. This is where it's nice that this is a belt drive. Because, dummy that I am, I just ran this right into the chuck jaws. So, man, that's a nasty looking cut. Doesn't look like I bent the tool post at all or anything, so. Alright. So obviously I've got this too far in. So let's pull this out some. So this has got a really sharp point on it, this cutting bit that I've got in there. So that's for roughing or threading or something, but it shouldn't be for, if I want any kind of a finish on that, that's half decent. I shouldn't be using this. Alright, so now alright. I'm going to go find a cutter with a radius on it. Alright, I found in my vast array of stuff this cutting bit right here. This looks like it might be a carbide tipped brazed cutting bit, and that's definitely got a radius on the end, more like what I would expect to see with a cutter for getting a better finish. So I just got done setting this up with blocking in this holder so that it's on center or just slightly above center of the work. So hopefully that's going to work. Well, I just had to change my setup because I thought I had that on center or slightly above center, but the mistake I made was I ran the carriage down here and lined it up with this live center that I have in the tailstock here, thinking that was a good idea and totally forgetting about the fact that I've got this extended so far that yeah, that wasn't going to be accurate at all. So now if I had it fully seated like that into the taper, now it's rigid, then at least I'd be in the ballpark. Alright, so I'll give you a look from this angle here just so you can see my setup and the angles that I'm dealing with. Hopefully I'm close to where I should be, and I think we're going to try a little bit higher speed and a lighter cut to try and clean this up since this is so rough. Hi everybody, I'm going to interrupt this video right here because the consequences of the crashed hard drive have reared their ugly head once again. I've lost some video footage. I was in the process of using the Atlas lathe to turn a piece for the elevation assembly here. So here's the actual finished part. So here's what the completed part ended up looking like. I turned it down to a diameter that would fit inside that bottom part, and then I actually drilled a hole through it so I could push the pin through to hold this on. And then the theory was that this was going to basically, when the inner screw turned up, it would rub up against the bottom of the outer screw and then start turning the outer screw. And what ended up happening was I ended up installing this and finding that it didn't work anywhere near as well as I thought it should have. So I ended up taking it out and not going with this. So all that lathe work was, well, I wouldn't say a complete waste of time because I'm a novice beginner at running a lathe. So it was fun to mess around with. So that leads to the question of, well, how did I end up eventually fixing this and putting it back together? What did I end up doing? And I wish I could answer that question for you, but this was actually over a month ago, and I have forgotten exactly what I ended up doing. I think I ended up just putting that pin back in and leaving the pin so it stuck out enough so that as the inner screw rotated and got to the end of its limit, that pin would hit that little groove that was in the bottom of the outer screw. The end result was that I put it all back together. I used the Harbor Freight shop crane there. I used that to actually lift the table back on. I've got the jib, the broken jib I've actually got on here temporarily, just for the sake of keeping everything together so I could try it out. So I'm going to be taking that jib off and doing that repair I talked about at some point. For the time being, it's actually on there though. And then I ended up having to use a putty knife to scrape down some buildup that was still on the ways here. I'm calling these surfaces the ways for lack of a better term. And then I lubed it with 90 weight gear oil. I have some extra gear oil, and I wanted something that was a heavy enough oil that it would kind of stick somewhat and wouldn't fall down. Obviously I could get a dedicated oil that's used like on the ways of lathes, like Shell Vactra or something like that, but I'm not buying that right now. So I just wanted to show you guys that it works well. It does exactly what it's supposed to do. You can see, obviously going down is a lot easier. You got the weight of the table helping you out. Going up, not bad at all. And I also, when I put this shaft back in, I put oil in these two holes here to lubricate this shaft. Everything went together really well. So as I raise the table, eventually what happens is this inner screw reaches the end of its travel, and that pin that you can't see inside there, down inside here, will actually hit the bottom of this outer screw, and it hits that little groove and starts turning that outer screw. And then there is a physical stop. But there's a way that keeps this from being able to unscrew all the way. I think it's a set screw if I recall correctly. Yeah, there's through the hole, access hole here, there was that little tiny screw. That screw actually blocks the groove at the end of this screw and keeps it from being able to unscrew all the way. Of course, you're not going to want to go any higher than that anyways, because I'm actually at the top of the table's travel right now on the ways. And then when I lower it, the outer screw goes down first, and then when it reaches the end of its travel, that will allow the inner screw to disengage from it, and now the inner screw goes down. So, pretty neat. And the whole purpose of this is because on other drill presses of this era that had that much travel of the table, they didn't use a telescoping screw, and what ended up happening on those is you actually had to drill a hole through the floor in the mill or factory where the drill was positioned so that the screw had some place to go. This way, by having a double telescoping screw design, you get that extra travel without having to worry about having a hole in your floor underneath here. So I just thought I'd show you guys that. And then of course the handle comes off and goes right over here on the locking, but this doesn't work because of course the problem with the jib being broken. But this is coming along nicely, I think. So I'm glad that this is all done. So the next video after this one is just going to jump to working on the some of the bearings and stuff on the head assembly.